So now we're going to look at structure-oriented filtering. So if we go to the main GUI, we go to structure-oriented filtering, select that. What we are going to do is open up our main seismic data, hit OK. We need to consider our dip because this is a geometric algorithm, so we want to run it along the dip. I'm going to put in our similarity, so in this case I'm just going to use our energy ratio similarity broadband that we calculated earlier. Got all of that filled out. I'm going to select my parallelization to 10. Alright, let me scroll down a little bit. And some of the things I want you to select for this first time is to look at the PC filter data. Let's look at the output rejected noise for each selected filter. And yeah, and I think that's good. So we will execute the structure-oriented filtering now. Okay, so our SOF 3D completed. So let's exit out of the normal completion window and do a little bit of visualization to see what happened. So we will go to our 2D plot here, and I will find in all of these the SOF. So pretty much everything does get recorded. Okay, it should be under D, PC. Alright, so first we can look at, we'll pull up a few of these. The filtered. We'll just look at it in a time slice. Yeah, that's all of this is good. So let's just look at, hit execute. Alright, so this is the data that has been filtered using structure-oriented filtering. We can look at a few other products. Let's look at the noise. So I always like to start with the noise, as I mentioned before, because it's good to know what you're throwing away. So let's pull that up, and here we go. Spend a minute on this just looking it over. So as I make it bigger, you can see all of the noise that was rejected in structurally oriented filtering, and this should be something to look at in order to assess if you think that you're throwing away too much geology. So we can definitely see that there are some geologic features that we're throwing away as we move through the data. And so depending on your area of interest and what you're looking at the data for, that would be important to look at. You can also look at the mean filtered data that was removed during this process. So let me see if I could find that in a timely manner. Oh wait, maybe it's under D. And I couldn't find the mean data, but that is because I didn't select it. So I went back to the GUI right here, and you can notice that I didn't select my mean filter data. But that is something else that you can do in the structurally oriented filtering program. So what I would suggest from here is that you can go through your seismic data, you can look at the rejected noise, you can try to apply some different window heights, different window radiuses, and even if you have noise around your faults, you could see there's some edge preservation parameters. So those are other parameters that you can kind of tweak and try to get the optimum amount of noise removed in structurally oriented filtering, but not too much noise removed.